I'm Jacob Cherian. I'm the Vice President of Product Strategy and Product Management for Reduxio. I've here Eyal Treitel, who's our Director of Technical Marketing. And back there, most importantly, is Nir Peleg, our CTO. He's the brains behind what you're going to see here. So I'm going to try to explain what some of the ideas that he came up with. So thank you to the architecture. Just to give you an idea of the roadmap of what we're going to do. We'll talk about the architecture of the product, what makes us unique, right? The product itself, the use cases that we're going to focus with for the product when we first go to market, which we're in the market right now. So that's what our plan is as we project customers. And then we have a demo of both recovering a database using backdating, which I'll get into more detail about what backdating is, and recovering a virtualization environment using backdating. Sound good? Okay. This is Reduxio Systems. We're building enterprise flash hybrid storage, and I'll explain what that is. We're headquarters in San Bruno, California. We've raised about $27 million from Seagate, Intel, JVP, and Carmel. We're about 3 years old. Where the team comes from NetApp, Dell, Oracle, IBM. And we have about 15 patents that cover our core technology, okay? And we're more in the works, so that's kind of the IP that we have. Next slide. Okay, so the genesis of Reduxio came from an idea that, the storage industry has changed so much that every time a feature came up, a new media came up, some change happened in the storage industry. Storage vendors constantly, what they did was they went to their metadata, they basically added bolt-ons to it, right? New features were added as bolt-ons to the existing metadata structures. Sometimes they were successful, sometimes not so successful. So you basically ended up with these systems that features kept getting added, and it became more and more difficult to add new capability, right? So this is kind of the world that we saw. I came from storage. I spent 14 years at Dell. Nir was a founder of many storage companies. Our other founder is also a founder of many other storage companies. Our CEO comes from NetApp. So, we looked at the market and said, hey, people are adding feature capabilities to metadata's architectures that were fundamentally designed at a different point of time and not really intended to, have these features. And so the question we asked is, can we come up with a new way of representing metadata that makes all these features just built into the system? Now, when we said features, we basically looked back and said, what are customers trying to do with these features, right? If you think of most storage systems, the feature capability that they provide looks pretty much the same. The innovation is really in packaging, the scale, the performance, but the feature capability seems to look all the same. So what we did is we asked the question, what are customers trying to do with the features that they have, and then see with our new metadata, is there a way to solve the problems in a better way? Okay, so that's the genesis of a lot of things that you're going to see here. So what we said is we need to come up with a new metadata representation. Next slide. Okay, so this new concept is encapsulated in our storage OS, which is called the Time OS. Okay. The core principle of our metadata is different from what you've heard from any other storage vendor. In every storage system I've worked on, core metadata tracks location of data. Where does data live, right? In our system, core metadata does not track the location of data. It tracks the fact that a write occurred to our system, an update occurred to the system. For every update, we record that, and we record the time the write occurred, okay? We have a second layer of metadata that tracks where the data eventually lives. And that's a very powerful concept, right? It's very, very powerful because it does two things. The first thing is we know the life of a volume. Any data container in our system, we know the life of that volume in terms of IOs arriving on that volume, changes that happened on that volume. The second thing is volume definition is completely disaggregated from volume data. A volume is just a container through which a host accesses data, right? It's a representation. It's a logical representation. And that representation is disaggregated from the data itself, right? And this allows us to do a lot of cool things. Think of what you need to do dedupe. In dedupe, what you essentially have is disaggregation of volume from its data because you have multiple volumes that share the same data. Think of what happens when you do tiering, right? Data moves around between the tiers, but the volume continues to exist the way it is always, right? So the idea that volume representation is disaggregated from volume data is core to our metadata, right? And also the idea that we track updates to our system. And what does this allow us to do? It allows us to take any volume in our system and go back in time. When we say go back in time, this is not an operation you need to do, right? If you think of how we go back in time, all we're doing is giving you a view to the volume the way it was some point in the past.
So I create a new volume that represents the existing volume at some point in time.
In the past, yes, you can.
Okay.
Yeah?
So you've got CDP cooked right into the storage system.
CDP is a concept that came from backup, so we don't like to call it CDP, we like to call it backdating, right? This is built...
Call it whatever you want.
Yeah, it's built into the storage system, yes.
I typically refer to it as CDP is A to B, and what we're doing is A to A,
right,
because it's within the same system.
Right, it's not, it doesn't provide the location DR capabilities that the products that used to be CDP did.
Exactly. Okay.
And I can set, and how do we handle retention?
Okay, I'll get to that. I'll go to the next slide. Okay, so that ability to go back in time is called backdating. We're calling that feature backdating. We can actually take any volume, go back in time at the granularity of 1 second. Okay, and the way you go back in time in 1 second is by either creating a clone of the volume or by actually doing a revert operation. Okay, so now clones in our system are first level objects, which means they're not tied to their parent. You can come and delete the parent, the clone lives on. You can create 5 levels and delete the odd levels, and the clones continue to live. So anytime you create a clone, it becomes a first level object in our system, right? Now you asked a question about how we manage retention. There is no configuration in our system with backdating. When the system comes to you, you create a volume, the volume automatically starts recording its history. Okay?
Right.
Now, you have a policy on the system that basically dictates how we manage history, and that's applied by default. You can come and change it. The default policy on a system keeps about 8 hours of per second recovery, and then then it gets thinned down
and then
to
longer retention with coarser granularity.
Coarser granularity, exactly. And then you can come back and if you basically say, hey, I have this we provide 5 policies that are canned. You can come and change any policy. Any volume that has policy, once you change the policy, the impact is retroactive, right? So it goes back and applies to any policy that has that policy, any volume that has that policy.
And if I'm really paranoid and want to keep a journal forever, I just have to pay for the space.
You have to pay for the space, exactly.
Okay.
Exactly.
So so snapshots are level 1 objects. Is that a full copy of the metadata or a difference from someplace?
It's if you go back to the previous picture, the way we like to describe the difference between backdating and snapshots is an operation you do, right? When the storage system does something when you take a snapshot, it copies the root pointer of the volume, it points to the same data. When a new write occurs, it allocates a new block and keeps a new block in a new location, right? This is not something that you do. We're recording the history of a volume, and when you say I want to go back in time and see the state of a volume, all we're doing is we're providing a view into that point. So there's no operation.
Well, I mean, you have to build the metadata to present the view.
No, we don't. The metadata is ready to go. The way we'd like to describe it is a volume now is no different than a volume 1 second ago, or volume 2 seconds ago, or volume 3 seconds ago. Well, the only difference between that is...
there's just the metadata response that has to be there to be able to do the presentation.
Exactly. Right.
These are like
queries.
It's got to have a LUN ID, so you got to create that metadata.
There is no operation involved. Right?
Okay.
To go back in time, there's no operation. You just go back and say, I want to go to that point in the past that I've recorded, and I want to see the volume it was in the past. So this is very efficient, and there's no performance impact for us to actually take you back in time and go see a volume the way it was in the past. Right? This is completely different from the idea of snapshot, because snapshot is an operation you do. Backdating is a thing that runs all the time in the past, and we're giving you a view into where the volume looked like in the past.
So how
I don't know that you're actually being clearer by insisting on using your own terminology.
Yeah, I'm struggling with how you're not using insane amounts of storage on the back end
Okay,
to
so,
accomplish this, especially once, back to the second.
yeah. So, and I'll cover, so there's two parts to that question, right? One is how much metadata are we using? Snapshots by definition, because you have to copy the entire root pointer of the volume, are very inefficient. And we're not doing snapshots, which is why this time recording is important, because it allows us to do a very, very efficient metadata representation for a large amount of historical data that we keep. And Nir can get into the details. Some of this is very proprietary on how we actually do the recording. But Nir, what is the average overhead of metadata for a history on the system?
Everything from 1% to 4%.
1 to 4%. That's the metadata history.
That's just the metadata, because you actually need the data.
Yes, we need data. Exactly. And from the, correct.
And so it depends on your change rate and the granularity
exactly.
that you're maintaining.
Okay.
Which is not trivial. It's like, yes, it's simple to understand, sure, but it's super important, because as you mentioned, this is continuous data protection type
Correct.
stuff. So if you're changing stuff a reasonable amount, that's a lot of storage. Great for you guys because you can sell lots of it, but yeah, we need to understand a bit more about that.
Sure. Go to the next slide. Okay, the one after. Okay. The other property of backdating is this notion of automatic consistency, okay? Now, if you're familiar with consistency group, everybody's familiar with consistency group. If you have an application that's on 5 volumes and you want to take a snapshot, you want to take a snapshot of the consistency group, right? Because you want to get it consistent across all the volumes. We don't have consistency groups in our system. The system is automatically consistent at those 1-second timestamps. So if you have an application that, you had a question.
No, I'm just thinking it through. So yeah, so
So if you have a database that's sitting on 5 volumes, and you have a problem, you roll back the database, all the volumes on which the database lives, to the exact same time in the past, to the second. You get the volume, the database the way it was at that second. And this is something that Eyal is going to show you.
So that would mean that
So that
beyond that, it's like, because one of the other issues, good, consistency groups, fine, database thing, awesome, but I've got 7 other applications and systems and they all need to be consistent at the same time.
Exactly.
Like, people don't do that. So that is very cool.
yeah,
You can do
but-
that.
That's a hard thing to do with multi-application
it's storage
consistency.
consistent, not application
Correct.
consistent.
Yes.
Correct.
Now, can I annotate the metadata stream to create application consistent recover points?
Ta-da!
Okay, but does that tie into, say, VSS?
Yes.
Okay.
So what you can do is you can come and name any point in time in the past, right, with a
Keep
label.
answering the question. Keep coming up with the right answers. We're good.
Yeah, it's good.
We'll keep asking questions as long as you don't get them
Yeah.
wrong. We're happy.
So the way we do that is if you do a VSS consistent snapshot, right, what we do is we basically put a special label on that timestamp. But you can also come and configure these timestamps, right? If you say, hey, I applied an Oracle update, I want to capture that timestamp, you go and write the thing, and you set a retention policy for every one of these bookmarks. They're either tied to the overall retention policy for the volume, or you can basically say, I want to manually manage the retention, which is, it is kept forever, right? We have, in fact, this is a use case that somebody came to us and said, hey, we could use this for this. They're a company that does analysis on compliance data, and they basically said, we want to put a hold on data forever. So we said, well, this is not what we built it for, but it's cool that you can use it that way. So they take a bookmark on the data, they bookmark and put the retention policy of the bookmark as manual, which means it's just preserved forever.
Okay.
That is very cool.
Remind me when you get there. I got lots of questions on the hardware to support that.
Yeah.
Okay? Okay. What I want to do is I'll take a break and let's cover the questions on this topic, and then I'll go into the other 2 pieces of technology that are core to our system.
I think I got this.
Okay.
Yep.
All right.
It's
Right.
like the ramifications of this are going to be hard,
That are significant. but
Well,
yeah.
the storage system this runs on, I want to be very much scale up because I'm going to keep a lot of 7,200 RPM drives with this cold data.
As soon as we give this to legal, they'll just go, yes,
Right, yeah, no,
I'm going to use it for everything.
Right. If the system does this, I don't want 10% flash. I want 2% flash.
Yeah.
Because I'm going to have a lot my heat map is going to be completely different.
Yeah.
So
And then the whole, you have to keep a whole lot of data you brought up, Teresa, becomes, they're just 7,200 RPM drives.
So I'll answer that question a slightly different way. We could do that, or we could move it off the system, and I'll cover that when we come to tiering.
Oh, now we're getting cloudy.
You didn't say that. I never said that.
Am I going to move it off? Tape?
Maybe. Now, one thing I didn't cover on the metadata
In the
is
cloud.
one thing I didn't cover on the metadata is because we separate that core metadata, which controls the representation from the location metadata, we're really agnostic to the block size of the media. Okay? Because once you break that apart, what you can do is you can pretty much address any kind of media from our system.
I think I know where
Natively.
you're going. Just keep going.
Natively, right? We can.
This could be really good. Keep going.
So, and this is not in the product, right? I'm just saying that this is what the architecture affords us to do.
Tease.
So, important concept, which I kind of missed when I talked about the metadata. This is No-dup. This is the other pillar of our technology. This is inline, in-memory, global, always on dedupe and compression. Okay? Basically, the way No-dup works is data comes into the system, it comes off the wire, we apply dedupe and compression to the data, and it's globally deduped and compressed across memory and all media tiers. Now
So you're deduping before you put it in the NVRAM cache?
we dedupe it before we put it in NVRAM cache. Yes.
So you're deduping before you're acknowledging?
We're deduping the data before, no, the ACK goes out at the same time. But once we find out we have
So you accept it to NVRAM, you ACK it, and you hash it so that it doesn't take up any more space, as much
no,
space
the hash,
anymore.
the hash happens as the data comes in. And the only thing we need to do is find out if we have a copy of the data anywhere in the system. Okay? That's all we need to do. And then we place, if we have the data, we go fetch it from where it is, right?
Okay.
That's it. So memory is deduped and compressed. Now, if you're
Now,
running an application,
It says RAM there. You do mean NVRAM, right?
it is RAM, which is protected by mirroring, and it's protected by a cache protection system. So it acts like an NVRAM. Okay? It's a DRAM cache that's protected, which is protected against power failure. Will write the data out to solid state to stable media.
I mean, Extreme IO tells me that too, but they protect their memory by having UPSs on the appliances.
Yeah.
We don't do that. Not a good, we don't like that.
Thank you very much.
We don't like that. See, we want to deliver something that you can just take and install and be ready, running in 15 minutes.
Okay.
And I'll show you a customer code at the end, but that's what we wanted to get to, and I think we have. The interesting property here is when we do tests with many servers booting, when we stimulate a boot storm, what we see is we see the first read going to SSD or disk to fetch that Windows image, and then we see no I/O on the back end, because this just runs out of memory. So this is a very, very powerful concept. Plus, we think always on is a right way to go for dedupe and compression for this space, because the media you want to maximize is the flash, right? This is the constrained media in your system. This is the expensive media in your system. So you should not have the case where you say, well, if you want performance, turn off dedupe and compression. That makes no sense. There are people who tell you that.
Only
What's the overhead? Well, at least for the compression piece.
We do great performance with dedupe and compression turned on, which is why we decided to leave it on, right? If we thought that this was going to create a problem, we would have actually said, okay, this is an optional feature.
Yeah,
we actually deliver great performance with dedupe and compression turned on. And so we basically said, this is the right thing to do. Plus, this is what we wanted to do, right? Which is have compression and dedupe turned on all the time. Now, if we ran into a problem, we would have thought of turning it off, but we don't have a problem with performance.
what's the overhead's actually a difficult question, because it implies it can be turned off. And on a lot of on systems, there are a lot of systems that use the hash to determine where the data is going to be stored. And so you can't turn the dedupe off, and therefore you can't calculate what the overhead is. you just have to look at how fast is it with the dedupe on, and is that fast enough?
Exactly. Okay. So this is no-dup. The next one is TRX. Okay. This is, think of how people have built hybrid systems in the market today. Most of the hybrids on the market today are of two types, right? You have the tiering hybrids, which is what a lot of the legacy storage vendors did. They basically took flash, put it on top of spinning media. The quick way to integrate this was using post-process tiering. You build context of a long period of time, then you move data in bulk between the different media types. Once every 12 hours, once every 6 hours, you give a button to the user saying, tier now, right? That's the state of the art in the tiering world. The problem with that is workloads can't sit around for people to come and hit a button, and workloads can't wait for 12 hours for data to move around, right? So you really have this problem where data is sitting in the wrong tier and it doesn't come into the right tier at the right time. Now the other approach, which has been successful, is to use SSD or solid state media as a cache for spinning media, right? Now caching works, caching is very reactive, right? But the problem that we think caching is going to have is, the first one is tiering is always going to deliver a lower cost solution to the customer when you combine two media types, because you're able to take advantage of the capacity that you get from both media types, and that's what you deliver to the customer, right? If you take a system that has 2 terabytes of SSD, 10 terabytes of disk, and the system is a caching system, the customer gets a 10 terabyte system. If you take 8 terabytes of SSD and build a system that is 8 terabytes of SSD and 10 terabytes of disk, the customer still only gets a 10 terabyte system from you if your technology is caching. With tiering, you get a 12 terabyte or an 18 terabyte system. So naturally, the dollar cost per gigabyte delivered to the customer is lower. But the problem is, I'll get to that, but the problem is tiering is not very reactive, right? Tiering as you know it today is not very reactive. That's what we have solved. We have come up with a tiering architecture where we're able to move data very quickly, like a cache, between the different media types. And that data is dedupe and compressed, and that's what gives us the performance. Now, this is a hard problem to solve. This is another core part of our IP, is the idea of media awareness. To do tiering effectively between different media types, you have to be media aware. You have to be aware of the properties of the media that you're reading from and the properties of the media you're writing to. Otherwise, you actually end up killing the slower media when you move data around. So that's another core idea of how we collect data together when we do data movements, so that we're actually not killing the performance of the slower tier. Now, this is fine-grained tiering. We're not doing tiering at 15 megabytes or 300 gigabytes, where all our heat indices in our system are kept at 8K. However, when we move the data, we try to predict what data goes together, and then we do the data movement. Okay, so this is TRX.
And data is promoted and demoted continuously?
Continuously, yes.
Okay, I have a small bone about the tiering being a second copy. Because tiering, the copy in the flash is the first copy.
Right.
The one on the backing store on the 7200 RPM drives that cost me 7 cents a gigabyte is the second copy.
There's no second copy.
In a tiering system.
We only have one copy of data anywhere in the system.
I'm not saying in your system.
Oh, okay.
Right. Your argument that the efficiency of tiering matters, I think, is moot, because I'm not buying more flash capacity. I'm buying more really cheap 7200 RPM disk capacity. And so then, yes, if I, as you explained it, if I have 2 terabytes of flash and 10 terabytes of disk,
yes.
In one case it's 12, in the other case it's 10. But if I want to have 12 terabytes of total capacity,
right,
then I need another $400 hard drive on a $30,000 system, and I don't care.
That equation is right if your hybrid is
I'm assuming a
flash
certain amount
and
of
disk.
efficiency.
Flash and disk.
Yes.
Okay.
If the capacity tier is more expensive than 7200 RPM disks, you might have a point.
Yes, and it could be. And that's the beauty of a tiering.
3 years from now, the capacity tier will be flash and the performance tier will be something new.
There's no reason why
point or something. Yeah.
There's no reason why this cannot be 2 different types of flash either.
Like all of your peers in the hybrid systems have been announcing over the past couple of months.
But they're caching tiers, right?
It's still,
It's similar.
2 tiers of
Yeah.
flash.
But can I put it on, for example, tape?
Say it again.
Could I make
No,
my capacity
we
tier
don't. We
tape?
don't support tape today.
Okay.
We can. The idea is we can natively address other media types. We're definitely going to look at what is the right way to build additional hybrid systems where we actually can support multiple media types.
Yep.
For us, the effort to add another tier is pretty trivial. So we could foreseeably build a system that has a different mix of different types of media.
Yeah. Well, and for example, some of the other things that we've seen today, I can see that you could use, for example, clear sky data as a tier, as something that you're not using very much it sits all the way over there, but it's well protected and everything else. And I don't use it very often, but I do want to be able to get it back. So, yeah. How does so you're saying that there's not multiple copies.
Yep.
So how do you move things that aren't, if it's not hot anymore, it's now cold? So does that mean, and I'm thinking of how that works in conjunction with the time tracking and CDP function that you've got. So does that mean that you're moving the metadata about where the block is located independently of the time that the update occurred?
Nir, do you want to try to explain kind of how the tiering works?
Okay, so
At a very high level.
Yeah, we'll let them get away with that.
Well, we'll see.
so
It's on. Yeah.
first of all, we try to understand which blocks go together. So it has to do with the way they were written. Blocks that are written as a continuous stream, we will try to keep them together. Okay. And also, it depends on the way they're being read. So we read frequencies and patterns, and try to understand how the data is being used.
So you're keeping I/O adjacency metadata?
Yes.
Yeah. Yeah.
Okay.
It's both. We look at both temporal and spatial, right? That's
so if
we look at it.
If I
Yeah.
got an application that's doing 64K writes, you're going to promote 8K blocks at a time because that's how I'm dealing with it.
Exactly.
Yeah.
Right. So, and then at a lower level in our tiering algorithm, we try to cluster multiple adjacent blocks together. So if you have even unrelated blocks, they will be clustered together in order to be written together to the slower media. So we actually write the slower media in 1 megabyte chunks as opposed to the.
Okay. Yep. That's a sort of a destaging operation. Yep.
Yes.
Okay.
Now that may, when we promote data back from the slower tier, that may create holes or may force us to do garbage collection on the slower tier, which we do.
Yeah.
Okay. Right.
It's a write and free space file system. Eventually you have to do garbage collection.
Yep. Yep. Okay.
Okay. I'll quickly go over what the the value proposition for Reduxio. The one is backdating. We can recover applications to any second. Flash for every application. We think we can deliver flash storage at a price point that is much lower than anybody else in the market. And if you think of the way our flash system works, we really look like an all-flash system that's able to move old data to spinning media, as opposed to a system that accelerates spinning media using flash. That's just the way internally the system is designed. We do inline dedependent compression, then we move old data, cold data from the flash tier, the fastest tier, into cheaper tiers of storage, right?
So it's flash first.
It's flash first. It's always flash first, yes.
Yeah.
And eliminating complexity, and I think you'll kind of see this when Eyal does a demo. The whole design of the system, the whole every feature that we've designed, it was intended to look at what is a customer trying to do, and not try to just implement a feature because every storage system is expected to have it, right? Which is, I've worked on multiple storage stacks, and you kind of start with the assumption of how do I do a snapshot better, right? You start from there instead of asking the question, how do I allow customers to recover applications, right, in the best possible way using data that is kept locally on the system, right? So once we started that way, we asked that question in a lot of different places, and what we have come up with is a system that's very easy to use, very easy to deploy, We had a customer which was a beta customer. When we went in, from the point he racked and stacked the machine, he assigned the first volume to his application in 15 minutes. And then he basically said, this is really cool. The last system that was here took 4 hours for me to actually get to this point. So, we're very proud of the work we've done in actually simplifying the entire usage model for storage for data users. And I think, you'll see that in the demo on how we actually simplified the usage model for storage.
So when I think about data moving, I feel like databases are probably where you're going to get like the most bang for your buck with something like this, because there's going to be likely a lot of change going on. How does something like this work? Okay, yeah. It's a use case.
That's our focus use case, right?
Okay.
We really think that customers who are actually doing database in production and database development, they will really benefit from Reduxio storage. We have customers where we were able to go in and say time to recovery reduce time to recovery from 6 hours to 6 seconds on MySQL. We can do SQL Server back to the last second, Oracle back to the last second. And then the other one is, of course, virtualization, right? Everything today is deployed on virtualized servers. This is, of course, something that we have to support and we support.
I question the Exchange databases a little bit. Microsoft is a little bit finicky about things like that as well and how it behaves. So what kind of testing have you done there?
We've done a lot of testing. We can always recover Exchange.
The databases?
Yeah, the Exchange database, yes.
Always on clustering as well?
Always on clustering.
Like Microsoft's always on clustering? Are there
SQL,
testing
right?
around that? Exchange is going more toward an always on type of
Which one
environment.
is it?
We've performed a lot of testing with SQL Server and Microsoft clusters.
Always on is the feature of SQL Server Enterprise Edition that
Right.
Yeah, it works. It works.
fail over
Right.
via
It
log
works.
shipment.
Right.
Yeah, it works.
2012.
It works.
Okay.
It works. Okay. I'll show you the thank you slide. That's the thank you slide. Eyal will do the demo now on databases.
Yay. Demo. Excellent.
We like demo.
Tech.
The pressure is on.
Yep. I'm here to assist if needed, but I'm not going to get in the way.
I'm going to leave at some point. It was great talking to you guys. I have to get to the airport. So
Sure.
Thank you.
He's got a really good excuse, so nobody can be proud.
Got that text that said, baby coming now, rush home.
No wife coming now.
Yeah.
Get married to Ron.
Oh, okay. Almost as good.
I had to clarify that because I
Whatever,
Yes, you did.
whatever advice we gave him, he didn't listen. So.
Well, congratulations.
Congratulations.
Mazel
Enjoy.
tov.
Okay.
it looks like it's working great, so I'm not going to go get it.
Yeah. At the end, native resolution still works, so pretty
So
good.
let's just let it go.
We will let it go.
And again, I don't know about you guys, but
It smells so good.
Yeah.
Okay.
He knows what he's missing. He can smell it too.
all right, guys, fantastic. You ready for this?
Yeah.
Can you introduce yourself at the beginning, and then we'll use that in the video?
Yeah, sure. Are we on? Yeah, we're on. Hi, my name is Eyal Tritel. I'm Director of Technical Marketing in Reduxio Systems. So what we'll do quickly here is do a demonstration of nice recovery of applications. So let me just kind of quickly review the environment that we have. We have this Windows Server 2012 R2. It's connected over iSCSI to these 2 volumes. Each one of them contains a SQL Server database. We've got the ERP in front end, the E and F drives. These kind of represent, databases, right, that make up a single business application, an ERP system with 2 pieces. I've got some SQL Server data in each one of them. And what we are doing inside SQL Server is I've got this simple script that runs and inserts timestamps into two tables, one in each of these databases, the ERP and front end. And what you can see is if I query, this is like a select queries for both tables. Basically, these are this is like the graph of the end of the tables. The end of these tables, continuously, the timestamps are increasing because I'm inserting new lines to the databases. So let me just do this fun part here of formatting the drives, simulating the disaster. So this is the disaster right there.
Okay, how many people in the room have done this?
So this is the disaster right there. Obviously, SQL Server doesn't like this thing too much, so it locks the drive. So I'm going to format both of them. And as I'm going to do that, I'm just going to I'll act as if I'm freaking out because my database is gone. And obviously, when you run the queries, again, they're...
You're not, your end users are.
What's that?
You're not, your end users
I'm
are.
end user, yeah. Call the system administrator.
Yeah, you
Call
won't,
the database
you won't freak
administrator.
out till the phone rings.
Exactly. So, I've been in support, so I know how it's like.
Before you do.
So, okay, it's all red. It's dead. So, let me just go to our Reduxio storage manager, which is our HTML-based, user interface.
Okay, no Java, no Flash, right?
It's basically JavaScript based, so it's kind of right. It's HTML5. Sorry, yeah, HTML5. So yeah, no plugins, no.
JavaScript would have been okay. It's Java and
Yeah.
Flash that are evil.
It's HTML5.
Yeah, it's a touch ready, touch enabled. I would say not touch ready, touch enabled user interface.
No, touchy.
You can see I've got some workload running here, and what I want to show you just a little bit. We're not close to the system here, so I can kind of flip it back and forth to see the behinds. These are the two controllers. This is the Reduxio HX550. This is the model that we're launching actually during the VMworld conference. And Jacob talked about this before with you guys.
And you publish the capacity via iSCSI?
Yes, it's published
and,
through.
And that's 10G base T?
Yeah, it's 10G base T. The 10G SFP plus. SFP plus. These are SFP plus connectors.
Oh, okay.
So
they look like USB.
You can see I've got some performance going on here with good, good throughput and IOPS and latency. And this is kind of our tiering page. It makes more sense to look at it like over a long period of time. So you can see I'm kind of feeding in. I fed 57 terabytes during the last 7 days, and after No-dup, I only actually written 3 terabytes to the SSD tier. And I've got some movements here from the workloads, so it's kind of bringing some stuff back from the HD, some from the SSD, depending on what I'm reading.
I like this.
Yeah, that's
So
cool.
it's active. I don't want to.
No, I like this, but since you guys are the continuous, I want to not have just a few choices on that over period to view it pull down.
Okay, yeah. Cool.
I agree.
It's because frankly, when I'm really worried about it, I'm going to be looking at what happened in the last 4 hours.
Yeah, cool.
One of those sliding windowy things.
Yeah.
that you can just- dynamic.
If there's
Yeah.
a trending, that's good.
Yeah,
feedback.
obviously we have a lot of information. Everything that I'm showing is available also on command line. You can.
It's early. Nobody's shocked. It's just
Yeah, you have some cool ways to pull stuff out on a regular basis, and we have nice JSON outputs and so on.
Question on the tiering, because seasonality is always a challenge when it comes to promoting data or not. So do you deal with things like an end of month finance run or
Yes,
batch reporting and so on? You detect that sort of behavior?
It's a kind of cool question. When earlier on I spoke with one of the bloggers, and he was telling me on one of the other solutions available where post-process steering, the guy runs a batch job at the end of the month, and until this thing ends, the post-processing tiering didn't even figure it out that this is the hot data.
Yep.
In our case, first of all, on the right side, it's always hot comes to SSD first. So on the right side, you're always kind of good. On the read side, we have smart algorithms that kind of figure out what is, we don't want to promote from HDD to SSD in all cases, right? In some reads, it would make sense, say a backup, right? You don't want to, every night when you back up the system.
You want to do sequentiality identification.
Yeah, you want to do some smart stuff. So we're doing this smart stuff ongoing to only promote, the blocks that are hot based on the algorithm. So we would definitely cover very well a scenario like that. So,
Okay.
But this this reveals the downside to tiering is when you're being reactive, you're doing twice as many IOs on the HDD
Yeah.
as a system that was caching, because for every byte that comes up, whatever was there has to come down. And if I'm just caching, when things go up, because it was just another copy, it gets discarded.
Throw away whatever it was. Yeah.
yeah, you know,
Yeah.
That's true in terms of amount of data that goes between the tiers. But because we cluster data in large chunks when you go to the lower tier, okay, so we
You're smoothing it, yeah.
yes.
Yeah.
yeah, sure. And obviously all the data in the system, you know, is you know, globally deduped and compressed. So that definitely helps, you know. I've got some fancy ratio here.
We're kind of assume that happens in either architecture. So
Yeah, okay. So let me go back to my poor database, right? We need to recover that and still be on time for dinner, right? So I've got the DB1 server. We've got these cool, you know, options to, you know, I'll just do an assignment just for fun. You know, I just assign with my finger just for fun. But anyway, we actually don't need to do that. We need to actually look for our volumes. So I've got the ERP volume and the front-end volume. And let me just look at those and make sure I'm kind of... So these are actually the volumes that I was using. Let me just... These should be the ones. So I'm actually going to go to backdating. And, oh, one thing I forgot, actually, I need to go back to the database. We need to find the time where the problem started, right? So I'm going to go to the SQL Server log file, and I'm going to look for the first occurrence of an error message in the database. So there must be some hole there where everything was running fine until 5:40:57 p.m. So that's my magic time, right? 5:40:57. Everything seemed to run fine before that. So 5:40:57, I'm going to go back to our interface. And what I'm going to do is actually, this was like 57, right? So what I'm going to do is actually going to go just a few seconds before that. Obviously, you know, we don't have much time, so I'm not going to play my luck. If I'm going to hit right that second, I may not be able to have a good copy just a second before the actual failure. So I'm going to pick like 53, just a few seconds before the format occurred. And I'm going to clone the volume. So this is clone number 1 is 5:40:53. And I'm going to look for the other database. This is front end. And I'm actually gonna clone that too to 5:40:53. Same exact second. So if you remember, Jacob was talking about consistency, automatic consistency. So these volumes are going to be automatically consistent between themselves. And one thing I actually have to do, which I kind of didn't do on the other volume, is to assign them. So let me just go to assign these volumes. So this is the first one. So we're going to assign it. Pretty easy to assign volumes. And I'm going to actually go to the ERP clone that I've created and assign that to. So this was this name. And I'm going to assign it to the DB1 server. Great. I'll go to disk management of Windows. I'm going to refresh the drives. And what I'm actually going to do is I'm going to offline these old volumes. These are the empty ones, just to make sure these are empty, right? They're gone. They're not interesting for me. So I'm just going to get rid of them for now. And I'm going to online the other ones. And Windows kind of assigns the same drive letters, so it's pretty neat. Okay, these were not the ones. I think I mistakenly chose the wrong volume name. Let me just make sure I'm picking up the right name. Might have been these ones. Let me try out.
The users get really upset when you mount the wrong database too.
Yeah, I have the wrong, I kind of cloned, that's the thing, I kind of cloned my volumes too many times, so I'm kind of confused by which ones are the right ones. Let me just make sure it's the right ones first.
Yeah, all those stormtroopers look alike.
Let me figure it out for a second. So these ones are kind of the original ones. And let me just, this is actually.
Okay, well, while you were busy,
Yes.
Justin and I figured out that we want you to have an API where our orchestration layer can tell you that at 2 o'clock in the morning, that tomorrow we're running the end of month. And you should promote those volumes now so that they're ready for us to run the end of month process.
So you can definitely do that today with command line interface. You can create
No rest?
bookmarks.
What is this, 2014?
It's coming up.
It's coming. I'll quickly answer the question. The entire front end is based on what looks like a RESTful API. We wanted to get the product out.
Yeah, no.
And making an API is more than, it's a little bit more than just saying, hey, here you go, guys.
Yeah.
So have fun with it.
How it's being perceived.
We have to make sure it's stable.
Yeah, it's fine.
This is something that's definitely going to be there. In the
From the 2014, it should have been clear. I was being
Meanwhile, it
facetious.
wouldn't be that hard to put some kind of scheduler in to be able to do this until you can get the APIs up and running.
Yeah, we were talking about
I
that.
can force a command into the CLI for now.
Yeah, and doing some of this stuff, like doing seasonality analysis and detection is kind of complex and requires some pretty funky statistics, so it actually makes sense to put that on a different system. And, we were just saying, there's a startup idea. If it doesn't exist already, there'll be one tomorrow of a virtual machine that controls not just this kind of system, but any system to do tiering promotion based on seasonality and that sort of stuff. So, if anyone knows how to write that and would like to fund me to do that, that would be cool.
You'd have to actually plug into the VIO filters to collect,
which we have now.
Collect the data.
Yeah, which we can do.
Right.
So, ta-da!
Yeah. Yeah, I mean, when I was running the university IT, it's like registration is the single biggest application that runs. It demands as many resources as you can give it for a week.
And it only runs once a year. And
twice a year.
Sorry, twice a year.
Right.
And you know exactly what days those are going to be. And so we built all sorts of scripts to, shut down all the test and dev stuff and
warm it up
warm it up and just, So, yeah, end of month is one thing. That kind of thing happens at a lot of places.
Yes, it
Yeah,
does.
totally.
Yeah, and existing
You don't need
solutions
this all
do
the
it very
time
well.
necessarily, but you need it for that week or those couple days.
And I know when I'm going to need it.
Exactly.
Okay, well, yeah. What I'll do here is I'm just going to go back to an earlier time from the original volumes, so excuse me for that confusion. Unfortunately, I ran this 100 times, and there's always this extra time that it fails. So you have to pick the right time, and you have to pick the right volumes. And somehow there was a mix-up here for some reason. So I'll fix that in a moment. I'll just unassign everything and
UI is a little bit confusing.
What do you mean by that?
I just find it a little bit hard to understand what's going on. It's a bit busy and I can't quite read. It doesn't intuitively make sense to me. So
it's, on the left side you have hosts, on the right side you have volumes, and you can assign in between them.
Okay.
So
well, that's okay today, but once I implement vvols, then the number of volumes expands so dramatically that you can't just have a list.
Yeah.
If I've got 20 volumes, it's easy. If I got 2,000 volumes, it starts getting ugly.
Yeah, we kind of added like filtering and search. So we felt that's, if you manage 1,000 or 2,000 volumes, our feeling was that you're going to use command line. So
Now, how would that work against the
I'll use
protection
an
by
API.
default as well?
what is that?
So you said earlier that all the volumes are protected by default, and with vvols coming into the picture, you've are starting to account for that in terms of how they're going to be protected.
So, we'll think about it when we get there.
Right.
Right now we don't support vvols, but it's easy for us to treat vvols as vols, and as such,
But they'll be treated.
backdate them.
They'll be treated differently.
You mean user interface wise?
Yeah, user
or,
interface wise.
We're not there yet. So,
Okay. All right.
Yeah, but it sounds like the system has sufficient metadata that you can just use your current LUN management for millions of LUNs.
The point is that it wouldn't be hard for us to manage vvols, except we haven't quite figured out how they're going to fit in our UI.
Well, frankly, neither is Dell. Okay, talk about the hardware.
About what?
The hardware.
The hardware itself?
Saw the back.
Yeah,
And
you've got
it looks like a storage bridge bay case, but what's in the front?
You want me to take this while you're trying to recover
I
your
figured
data?
it was something we could do while he was working. Yeah.
Okay, so the system is dual controller, dual Xeon processor per controller, 2 ports of 10 gig on each controller.
Okay.
128 gigabytes of RAM for buffering and
Hash table maintenance and all of that stuff.
and metadata. What else?
So what's
it
the
has
media?
24 drives at the front, shared between the two controllers.
Right.
Accessible to both. There are 24 drives altogether, 8 of which are SSDs, 16 HDDs.
Okay. And the HDDs are 7,200 RPM, 10,000 RPM.
And 7200.
Okay. But they're 2.5, so they're
Yes, they are.
So they're
Yeah.
1 terabyte today.
Yes.
Okay. And there's no scale up yet, right?
There's no scale up. At this point, we're designing scale up.
Yeah. It's begging for it.
Yeah.
It's just like, no, let me put another SAS, one of those 60 bay SAS JBODs on the back of this to hold all my old data.
Yeah, is it only scale, or is it scale up so it's not scale out, which means...
It
that's
means
the
it doesn't
architecture
scale
that you've
yet.
got.
So yes.
Yeah.
So in terms of architecture, we have designed everything for scale out. We have not implemented scale out.
Right.
Okay.
So
Yeah, so it doesn't
Good.
scale yet.
so in terms of the founders' DNA, we've all done in previous lives. We've done file as opposed to block, and we've done
Right.
scale out. I've personally done distributed file systems a number of times, including at Exanet, which is now like
Remember Exanet.
yeah.
Okay.
So we know what scale out is about. So,
Yeah.
and the system is designed for scale out. It's not yet implemented in the product.
Right. And it's iSCSI, which makes it a lot easier.
Yes, it is. Yeah, true.
Only iSCSI?
At this point, yes.
I like your interface. That's pretty clean and slick.
Yeah, we try to make it like very easy for users to be kind of self-service, very easy to assign volumes, very intuitive. I've written the documentation so that nobody will ever read it, kind of thing. So we do have full documentation, but the idea is that nobody is gonna ever need to read that. That's the idea. So yeah, unfortunately, I have some mix-up here of the volumes. Unfortunately, I'm still looking for the volume that was there at the time that I did this. Okay,
There it is.
looks. No, this. I think I had some problem with time here. Let me just go back a little bit further. This is during the format, most likely. So it's kind of fun. You can actually, because you can do every second, you can. If you don't pinpoint the right second, because you have some time issues or anything like that. I don't know. I synchronized the clocks just before we showed up. Maybe they went back in between. You may end up with something like in the middle of format or something like that, right? It could be.
It's the Tech Field Day demo gremlins.
Yeah, I know.
They tend to affect us.
I have recordings of these demos and everything was working fine and perfect. So
Fire up the recording.
yeah, I can do that. We're a little bit out of time. So
Yeah, we can actually, if you want to share the recorded demos, we can actually add that to the to this as well online. So there's no reason we can't post those or link to those.
Yeah. Okay.
Have it be an appendix.
That'd be good.
Yeah, maybe I can send those to you because there's no questions in between.
Yep.
Though.
Yeah.
From any blogger.
So yeah,
That's okay.
Well, and the audio and the video can get done separately.
It was 2 a.m. in the morning when I recorded it. There was nobody around me to interrupt.
And you get this group at 2 a.m., you got a wild party.
Yeah, exactly.
Are you kidding? We're old.
I got an 8 a.m. session tomorrow. I'm going right to bed.
Yeah, it's kind of a shame. I wanted you guys to see it live. But basically what I'm, maybe I'll just give up and if we have to go to dinner, is this goes on and I recover the databases, fine. And then basically I do the query. You see that the timestamps are actually going almost to the seconds before I actually did the backdating. And then you'll see in the videos I'm actually zooming out and showing that this entire thing is actually a VM. And maybe I can do that part, and maybe you can start from that part at least. So actually what I've showed you guys is that the DB1 machine is actually a virtual machine. So this is vCenter, and you see the DB1 machine running. So what I'm going to do is actually power it off. And the reason I'm powering it off is vCenter doesn't let you delete VMs that are powered on. So
Can't imagine why.
I have to first power it off. So I'm kind of powering it off, and then I'm deleting the VM. So now I have a really bad disaster because I lost the server too, not just the databases. So what I can do is basically I kind of powered it off at 602.16, and this is kind of sitting on a Reduxio system. So 602.16. Let me just go and access the system here. So this is located on the data store for ERP, and I'm going to find that data store. So actually, we're coming up with a plugin for vCenter. I'm going to show it briefly just for look and feel, but it's not fully operational yet, so I'll have to use the manual method of recovery, which is I clone a volume and connect to that data store. This add-on software, we're going to call it Reduxio Storage Manager for vSphere, is basically saving this entire, need to do this in steps. I'll show it to you in a moment in vSphere. So this is going to be just integrated and more easy. Now I have to do the full steps.
Okay. You said this UI is all touch enabled, so you could run this on an iPad?
Yes. We designed it so that you could run it on an iPad for management, and that's kind of the design concept is to be mobile ready, not just for monitoring, but for actual
actions.
For actual actions, yeah. Everything I do here, you could do on an iPad.
Yeah, because I'm noticing that you've got like nice big targets there for things like closing the window zones and selecting items and stuff.
Right. So that a fat finger will work.
Yep. Exactly. So let me just go to this data store, and I hope this will work fine. Because I'm kind of cloning clones. That's the fun part. You can clone clones. So,
can you clone clones of clones?
Yes.
You clone clones of clones of clones?
Yes.
To any level.
Yeah, yes. But eventually you become the Asgard and there's DNA degradation.
So I'll pick 602.10 as my target timestamp, and we'll call this 4, so I won't get confused. And I'm gonna just assign that you clone to the lab ES6 what we call host group. So host groups are just meant for ES6i clusters. So this assigns it to the entire set of hosts. And I'm going to go back to vSphere, go back to the hosts, rescan devices on the hosts. Going to go to adapters and then just scan the iSCSI initiator from VMware. Just go back for a second here and look at the WWID of the volume's 59. So I just want to make sure I'm looking at the right volume once the scan is done. Maybe in the meantime, let me just show you one thing. So I've got this plugin actually installed, and you can see the history here and bookmark tabs. This is how the Reduxio storage manager going to look like. You're going to be able to pick up the timestamp basically that you want to clone to right from vSphere, and you just hit create, and you're going to get another data store back to that second. So it's pretty cool.
That is pretty nifty.
What you need to do is just totally jank this up and make it, require, Flash or something, so that way it'll really fit in with vSphere.
What's that?
Make it look really ugly and require Flash, and then it'll fit in right nicely with vSphere.
Yeah, or you can make it run with the
We're a
version of
technology.
Java that's not
We're a
supported
VMware
anymore.
Technology Alliance partner.
So you're not allowed to criticize vSphere?
We're a paying partner, so. And actually, it wasn't that mentioned before, but we just won today the Gold Award in the VMworld show. So,
congratulations!
Thank you. We're good with VMware. We're good friends of VMware, like we should be. So let me see what we've got here on devices. I just want to make sure I have this device here.
Ready for long numbers. There it is.
Yeah, here it is. So I've got this one. So if I go to data stores, I'm going to actually add that as a new data store. This should show the new devices found that are not already data stores. So let me see, this should be, I need this one, 59. I'm gonna assign a new signature. It's kind of more convenient for the demo here. And it's gonna connect to this data store, and hopefully this should have my DB1 virtual machine back in there, back to that same second that I've chosen. So let's see. Just coming up. Okay, scan is over, so let me. This was actually, this should be this guy. Let me just actually, I want to take a look at the files in it. So I've got the DB1 machine, and all I have to do is register it again, and I'm up and running. So I'm going to pick the same original location where it was, same name, same everything, and it's pretty straightforward to every VMware administrator at that point. So now that it's back, I'm just going to boot the machine up, and I'm ready to go. So do you have any questions on that, or it's kind of pretty straightforward? So with the what we call Reduxio Storage Manager for vSphere, it's just a little bit quicker. I don't have to do the manual steps of creating the clone on the Reduxio side and doing the assignments and everything. It's just gonna be rescanning, and you get the virtual machine back to any second. So that's, we believe, is very cool.
Yeah.
So we actually do talk about data store level recoveries and VM level recoveries as well. I mean, I'm showing here VM level recovery. In a way, having this extra data store just for that VM may be inconvenient to some. What you can do is migrate that back into the original data store and then delete the snapshot one. Because we support VAI SCSI primitives, this migration this cloning migration is going to be very efficient on data movement because of VAI. So we support rapid cloning, rapid provisioning, and we've done a lot of optimization to be pretty quick. So obviously, because of No-dup also, it doesn't take up real extra space to do this copy and migration because it's all deduped. It's the same machine. So yeah, I got to tell it that I moved it. Yep, actually it should be here. Yep. I'll answer the question. Okay, that concludes the demo.
Cool.
Thank you.
You guys have any more questions or?
No?
Good.
No, I think, well, there's the one really sensitive question. How much does this fine technology cost?
Ask the sales guys.
Okay, so actually, that's the right answer because, but I can tell you that a 40 terabyte raw system is like under 100K.
Okay. Okay.
But for an exact price quote, you'll have to talk to our salespersons.
For what it will actually cost as opposed to list price, I have to take your sales guy and throw him in a corner and beat him up like I do real sales guys.
Would be a good idea.
I think the best way to answer that, I kind of relaxed from your question, so I kind of had the 10 seconds extra to think about it. So we designed the system to be highly efficient in the way it uses flash. Mm-hmm. And we put all the rest in disks. So that actually allows us to be highly competitive. When I'm on the, in our booth, if I look around, it lets me be very competitive compared to other architectures and technologies that are out there that are not really optimizing the use of flash because of different reasons. And we optimize it both by doing inline, in-memory, dedupe and compression, and because we do tiering at the block level, and these algorithms that let us be flash first and migrate the rest to disk. And I had an interesting discussion with someone this morning, and I told him, listen, it's easy to discount stuff, but the real way to make something with better price performance is only with technology. Only this way you can get to scales of difference, and that's what we believe we've done. So if you need more storage at home, Howard, talk to our sales guys.
I don't need any more storage at home, but the lab, I've only got about a petabyte, so could always use more.
You can always use some more. Okay, great.